because I realized I forgot. This will be a more serious talk, I'm sorry. But, a more scientific, serious talk. I'm Joel. I'm the head of the Human-Computer Interaction Lab at the University of Haifa. I'm also the head of the Human-Computer Interaction Master Program that we have. And this talk is going to be about infographics. But first, I want to introduce the team. It's a collaborative effort from 3 continents. People from China, Israel, the US, Hong Kong. So this work is really a collaborative effort, and led by Min Lu from Shenzhen University. So like I said, it's about infographics. And what are infographics? So they're information and graphics. But I looked for definitions. I didn't see like a clear definition of infographics. One is graphical visual representation of information intended to present information quickly and clearly. But for me, this is a bit too general. I think infographics are also designed, well-designed, usually handcrafted, and most importantly, they tell a story, or they want to tell a story, often opinionated, but they try to tell something. So if you take, for example, this infographic, you can pretty easily follow the flow. You can understand where to start, where to end, and where to how to read it. You can trace the graphical data elements that are in the infographic, and you can get the story from start to end. So we call this a visual information flow. So the visual information flow, or VIF, that's the flow of the story told by the infographic. And if you look at these 2 infographics, they're very different in design, but they have the same flow, which kind of goes from left to right. Or if you look at these 2 infographics again, very differently designed, but they have the same flow from bottom to up, kind of a zigzag way of showing the information regardless of the graphics or the embellishments around it. So the challenge in this project was to understand this visual information flow, to understand better how infographics are built and designed, right? To have a general visual organization of the storytelling, how storytelling is done by infographics. But this is difficult to do because designers, they design, and they design in very different ways, and most infographics are very, very different, with different appearances. Spatial arrangements are crafted, handcrafted, and are very different. So our approach, we took a data science approach, a big data approach, and we crawled, downloaded 14,000 infographics from design websites. We looked at FreePic and Shutterstock, and with the keywords infographic, we simply downloaded them. And most of the images we downloaded were design templates. So they were well crafted, well designed, and very diverse as well. So we had a large data set of diverse infographics. And then we looked at the model of infographic, and we, designers put things usually in layers. And in infographics, it's pretty clear. There's 2 main layers: the graphical layer, which is usually embellishments, ways to make it more visual appealing, and then the data layer. Data layer may consist of the text, the titles, the icons, and anything that is data and talks about the information that is within the model. And our pipeline was, first of all, to detect. I'm going to get into the scientific part a bit here. First of all, to detect the data elements, we used the machine learning for that, deep neural network approach to understand what are the data elements within any given infographic. And then when we had the data elements themselves, we tried to understand the flow of data elements. What is the flow of the visualization? Or not visualization, sorry, infographic. So looking at the first part, data element detection, we had an input, which were our 14,000 infographics, and using an algorithm called YOLO, a neural network algorithm, we wanted to label, to get bounding boxes of each element, data element, and to label them. This is text, this is numbers, etc. To do that, you have to have a training data set. Machine learning needs training, needs to understand. You need to have a good training in order to the algorithm to work. So we had over 4,000 manually labeled data. A lot of students worked really hard to get this labeling data. And they labeled, again, bounding boxes of the elements. And using the algorithm that I talked about before, YOLO, a neural network, we were able to extract for each visualization or each infographic the data elements. That's disregard the graphical elements and look only at the data elements, only the text, only the elements which depict data. And that was very good. We had a very good success in doing that. And the second part was to understand the flow. So if you look at these data elements, right, you can get a pretty good understanding of the flow. It kind of goes a zigzag, right? We can understand what the flow is, and indeed, this is a zigzag flow. And the reason you do that is because you use Gestalt principles. So if you take, for example, this image, right, something is missing here. And I think it's pretty easy, right, to see what's missing. The reason is, again, because we use various Gestalt principles when designing or when understanding infographics. A proximity principle helps us understand a group. Things that are close, we perceive as in the same group. Similarity principle, again, things that are similar, we perceive them to be in a group. For example, here, the similarity principle works on color. We perceive each color to be as a separate group. Another principle, a Gestalt principle, is a regularity principle. So groups are placed in harmonious patterns, symmetrical patterns. So the flow between groups is kind of symmetrical, harmonious. This often occurs in many, many infographics. So using these groups, we're able to make a rule-based algorithm that will detect the flow of the infographic. So our input was the labeled data that we saw before, and then we managed to make a traced backbone to understand the flow of the infographic and also associate groups. So we associated the small groups with each element. So we did that and basically had a flow and kind of an analysis for each data visualization in our 14,000 data set. We made a backbone. So the VAF backbone, Visual Information Flow backbone, is kind of the flow of this infographic. So if you see on the right, the infographic, we're able to understand the flow of data and the elements that are connected with each data element. So finally, we made a signature, a VAF signature. So for each visualization, we were able to make a signature which is composed of the backbone, which is the main thick part, and small elements that are connected to them. And we put this signature on a 100 to 100 pixel icon. So we had an icon for each infographics, and this is a bit complex. It's a nice trick for a computer scientist. This is a high dimensional. The 100 by 100 pixel is a high dimensional space. We managed using an algorithm called TSNE to reduce it to a two-dimensional space, and using clustering to detect various groups. So you can see, for example, on the enlarged part, you see many infographics are kind of in the shape of W, and these ones are in the shape of a line. Using all this, we were able to categorize the different infographics. And these are our main categories. So first of all, the 6 main categories are landscape, going like that, portrait, like that, a clock infographic which goes around, a pulse, which is kind of a W, can be other way around as well, spiral, again two-sided, and a star, and 6 more different categories of infographics: a ball, a down ladder, a left wing, a dome, an up ladder, and a right wing. So I'm just going to show a short video. it shows how through this two-dimensional space, it doesn't really matter how we got the two-dimensional space. We're kind of just using a clustering algorithm, being able to cluster the different groups. Okay. And we wanted to see if we can do something interesting, not only investigate or understand flows and how infographics go, but if you can use it for something more useful. So we built a search engine that works on top of these 14,000 infographics. And using this search engine, you can search for different patterns, different VAF patterns. You can search for a number of items and then kind of decide which infographic to choose from. So I'm going to show another video here. The thank you is for the video. It's not the end of the talk. I have 2
Okay.
Okay. Last thing we did is look at the data set, another data set of almost 1,000 infographics, just to kind of validate what we did. We manually identified, again, coding. Again, a lot of students worked hard. Manually identified the VAFs, so to see the distribution of actual data-based infographics. So interestingly, spiral was the heaviest or the most common infographic. Clock and portrait were also common. Then star, landscape. Also, there was 14% of infographics that we weren't able to categorize. It's interesting to look at them because not every infographic follows or has a visual pattern, a visual flow pattern. So the ones that we didn't look, we couldn't find a pattern, or first of all, a compound design, when you have a compound, a multiple design. Others were out-of-the-box VAFs, that's kind of crazy, very strange design that didn't fit any of our categories. Others were grid layouts. Sometimes people or designers put grid layouts which don't have any flow, don't have any order. And finally, just some infographics, without any visual information flow. So there are, of course, various infographics, and it touches the point of what is an infographic. Not all infographics look like this. There's various kinds. We used it according to queries. So to finalize, we explored visual information flow on a broad range of infographics. We used deep neural networks and Gestalt-based methodology to analyze automatically infographics to better understand what they're composed of and how they flow. We do have our tool, Infographic VF Explorer, and data is open for researchers who want to use this data. It's labeled data, So it can be used for other purposes as well. And now that's it. Thank you.